inverse sine function. So we would like to come up with the inverse of the sine function. We know in our regular sine function f of x equals sine x, what goes in are angles, or really you could say any number, as long as you think of it as an angle in radian measure. What comes out are ratios, or you could say coordinates if you're thinking of the unit circle. I've got the graph of the sine function over here. You can see the angles in radian measure here on the x-axis, and you can see the ratios like 1/2 or 1, or we could mark square root of 3 over 2, or some of the other ones that we've used. Those are on the y-axis. Those are the outputs. Well, we would like to talk about the inverse of the sine function, the function that reverses this process. At the start, though, you realize we've got a big problem because this function fails the horizontal line test. It fails badly. This horizontal line crosses an infinite number of times. Therefore, the sine function does not have an inverse function. Now, that doesn't mean we give up. Here's the solution. The solution is to create what we call the restricted sine function. The restricted sine function will be a portion of the sine function that does pass the horizontal line test. In fact, we want to take the biggest such section we can find. And the section that was chosen is this section right here, the portion of the graph that runs between negative pi over 2 and positive pi over 2. That's as much as I can go. If I go a little bit more to the left here, I'm going to start getting into a situation where I would fail the horizontal line test. Same thing if I went a little further to the right. This is as much as I can take and pass the horizontal line test. So the restricted sine function is the same as the regular sine function with the restriction that it only knows about angles that are between negative pi over 2 and positive pi over 2. Well, this function does have an inverse, and that is what we will call the inverse sine function. We write f inverse x, and then there are two notations for the inverse sine function. One way is to write sine inverse of x. Another equivalent way is to write arc sine x. Both mean exactly the same thing. This is the inverse function of the restricted sine function. So what does the inverse sine function do? Well, it takes in ratios. Will it take in any number possible? Well, you can see from this picture the highest ratio possible is 1. The lowest ratio possible is -1. So this function can take in any ratio between -1 and 1. What will the inverse sine function send out to you? It will send out to you an angle. And here's the very important part. The inverse sine function will not send you out any angle because it only knows about certain angles due to that restriction. We've already said that the only angles this function can deal with are angles between negative pi over 2 and positive pi over 2. It is extremely important to learn and memorize this information regarding the inverse sine function. Ratios go in only between -1 and 1. Angles come out only between negative pi over 2 and positive pi over 2. Okay, let's look at some examples. We want to evaluate each of these expressions by hand, if at all possible. We want to give answers in radians. The first one says sine inverse of root 2 over 2. Remember, what goes in to the sine inverse function is a ratio. That root 2 over 2 is a ratio. What's going to come out? What am I going to put over here? I'm going to put an angle. In fact, one very helpful tool is to read the expression sine inverse as the angle whose sine is. The angle whose sine is root 2 over 2. Okay, I want to work this out by hand. That means I'm going to be drawing either a unit circle if I suspect a quadrantal angle, or a reference triangle picture if I'm suspecting one of our nice triangles. Well, which quadrant should I draw my picture in? Inverse sine only knows about angles between negative pi over 2 and positive pi over 2. That's it. For an inverse sine problem, you would only ever be drawing pictures in the first quadrant or in the fourth quadrant. Now, this particular ratio that I'm given is positive, which means I must be in the first quadrant, right? All students take calculus. Sine is negative in the fourth quadrant. So I know I'm in the first quadrant. When I see root 2 over 2, that's supposed to make me think about the unrationalized version of that number, which is 1 over root 2. You've used it many times. I'm looking for an angle in the first quadrant whose sine ratio is 1 over root 2. Well, this should look very familiar. It's the 45, 45, 90 triangle, which means, of course, the angle I'm looking for is 45 degrees. In radians, that would be pi over 4. Second example says sine inverse of negative 1/2. Again, this could be read, the angle whose sine is negative 1/2. That negative 1/2 is a ratio. I can only draw my picture in quadrants 1 or 4. It's a negative ratio, so I must be down here. I'll draw myself a reference triangle picture. Let's see, sine is opposite over hypotenuse. So the picture must look like this, negative 1 over 2. Well, we've drawn this picture many times. It's just a 30, 60, 90 triangle in the fourth quadrant. I want to know the angle. Now, maybe you're thinking, it looks like it's going to be 330 degrees. 330 degrees is 11 pi over 6. Well, that cannot possibly be the answer. The reason for that is that the sine inverse function has never heard of an angle that big. It only specifically knows about angles that are between negative 90 degrees and positive 90 degrees. It's never heard of 330 degrees. So that is incorrect. You say, well, what angle is it then? Well, if you're in the fourth quadrant, you'd have to write down the negative angle, which of course would be negative 30 degrees, or in radians, negative pi over 6. That's the angle, the only angle that the inverse sine function knows about that has a ratio of negative 1/2. Okay, how about arc sine of 0? Arc sine means the same thing as sine inverse. Here's an interesting question. Is this 0 here 0 degrees or 0 radians? And the answer is it's neither, because it's not an angle. What goes into the inverse sine function is a ratio, not an angle. I will be looking for an angle right here in my answer. Now, what picture should I draw? Well, when I see a 0, I'm thinking, I don't think I'm going to make a triangle with a side of 0. So that makes me think that instead of seeing this as a ratio, I should probably see it as a coordinate. I'm always thinking unit circle when I see numbers like 0 or 1. So I'm going to draw a unit circle picture in this case. I know the unit circle definition of the sine function is that it returns to you the b coordinate of the point on the unit circle. Now remember, the inverse sine function only knows about angles between negative 90 degrees and positive 90 degrees. So I need to find a point on that section of the circle that has a b coordinate of 0. Well, I believe this right here is the only spot. This is the point 1, 0. There it is, a b coordinate of 0. It is the only such spot in that section of the unit circle we can look at, which means I think we've found it. What angle goes with that spot? Well, obviously it is 0 degrees, or in our case, 0 radians. Arc sine of 0 equals 0. This 0 is the coordinate. This 0 is 0 radians. Okay, how about arc sine of 2? Well, arc sine of 2, the 2 is a ratio or a coordinate. Do you see a problem here? We said earlier that the highest ratio or coordinate the inverse sine function can take is 1. There's no coordinate of 2 on the unit circle. There's no spot with something comma 2. It doesn't exist. That means arc sine of 2 is undefined. That just means it doesn't exist. There is no angle that returns a sine value equal to 2. Lastly, how about sine inverse of 1/4? Well, this is the first one we've come to where I can draw a picture. I know it would be in the first quadrant because the ratio is positive. And I can represent the opposite side as a 1 and the hypotenuse as a 4. The problem is we don't have a special triangle with those sides. This is the first example where I really have no option but to proceed to the calculator. We've used the sine inverse button before. It's right here in blue above sine. Now we have a fuller understanding of what it means. I am in radian mode, that's what we want, and so all I have to do is choose it and then insert 1/4 and hit enter, and we'll have our value. Sine inverse 1/4 is 0.25268. Again, make sure you're thinking about what these numbers represent. The 1/4 going in, that's this 1/4 ratio. The 0.25268, that's 0.25268 radians. That's theta. That's the angle in the first quadrant that leads to that sine ratio. By the way, since we have the calculator going, let's try that earlier example, arc sine of 2. I will type sine inverse. That's how the calculator expresses it. I'll put a 2 in, and you see when I hit enter, I get an error because that value just doesn't exist. Thanks for watching.